on our 146, E190 and Q400 fleet.
James Graham, Qantas Link on the turboprops out of Brisbane, and I'm one of the nominated SMEs UPRT program.
Greg Devine, Boeing Training Manager for Qantas Freight.
Good morning, everyone. Rod Yules, I'm the Projects and Quality Manager at Qantas Flight Training.
Morning, everyone. John Lamarquand, Airbus Training Manager at Qantas Airlines and part of the Qantas UPRT team.
Good morning, Matt Savage, my boss. I just work for the Qantas UPRT team.
Pete Spieth, another Qantas UPRT SME.
Janet Martin, Head of Operations at CAE at Moorabbin and delivering UPRT for the last 3 or 4 years now for different regulators other than CASA.
My name's Ben. Ben Wilkinson. I also do spin and aerobatics instruction and UPRT at CAE Oxford in Melbourne as well.
Goran Knezovich, Flight Training Manager at Pioneer Australia on the 146. So just looking to get some more industry experience in this department for us at Pioneer.
Mike McClory, Jetstar Manager Standards Assurance, just coming on board UPRT train.
Thank you. John McGregor, Jetstar Airbus UPRT team.
Simon Vanstone, the Head of Training and Checking at Rex.
Jeff Lowe, 737 at Rex.
Pat Murray, Head of Operations at Aviation Australia and Aviation Safety Advisory Panel.
John Frierson from Flight Standards Branch in CASA.
Thanks, everybody. All right, well, I'm going to hand over now to Roger, who's going to do his opening address. Thanks.
Thanks, Darren. If you could pop up my presentation, please. Good morning, everybody. My name is Roger Crosswaite, and I'm the branch manager for Flight Standards at CASA. My remit extends really to everything other than design, build and maintain aircraft, RPAS and medical certification and aircraft registration. So when it comes to the subject of UPRT, it fits very much into the area that I look after as far as policy and standards is concerned. While the presentation is coming up, I just want to quickly reflect back on where we've been for the last number of years. I don't know whether the last 3 years gone. I'm sure everybody feels the same way. 2019, when we were probably meeting last time, it just seems like yesterday. And to see the number of people online who also were at that meeting and where we're really kicking off the UPRT program for CASA. So it's been a long journey. What have I done? Nothing. It's very bad, isn't it, when something happens you haven't got control of it. It had nothing to do with the topic we're talking about today. There we go. Yeah, so here we are gathering again a good cross-section of industry and people from CASA. Thanks very much for coming. But also this time around, having those people online is really great. We've really come a long way in terms of being able to expand our network and reach out to people well beyond our shores. And I think that's added a significant dimension to the work that we get done and where we're heading to. Thanks, Darren, for your acknowledgement to country. And I'd just like to pay my respects also to traditional owners here in Sydney, the Gadigal people, and pay my respects to past, present and emerging. Very quickly, I'll try and keep my presentation brief, I just want to touch on a few points that that are topical for us. I think it's always important to take the opportunity when we meet like this to just cover some of the topics. I also want to start off by talking a little bit about the things that are going on at CASA and in my space. For those who are offshore, apologies, but I feel it's important to just touch base with the local people. Important part of our agenda for the last 12 months, and it will continue to be for some time, where we're trying to address issues, concerns about operations and what can we as the regulator do to improve efficiency and get better outcomes. The two that are relevant, I think, to this group is the flight examiner rating and the flight instructor rating. We're making changes in those spaces, and after 8 years of changeover from the old regulations to the new regulations, we've learned a lot. I'm prepared to say that some of the policies and the principles underpinning the regulations haven't necessarily been implemented the way we intended them to be. That's disappointing, but nevertheless, we have to move on and we need to reshape things, and these initiatives are very much part of that. Underlying those 2 points really is to drive more activities at the industry level and having responsibilities placed where they best action, which is key people within the industry. And both those two things are trying to do that. Our current focus is definitely the flight operations regulations. It's an enormous change, and we shouldn't underestimate the implications both of achieving implementation and also the outcomes that are embedded within them. And coincidentally, the current focus is on training and checking, making some rather fundamental changes to how training and checking is applied, but doing it as incrementally as we possibly can. For larger operators that have had established training and checking systems, it really is, not surprisingly, no significant change at all. But the changes do bleed down into the smaller end of town, which is where it's hardest to implement. And so the challenges in that sector should not be underestimated, and we need to work together to get to where we need to be. And I'm just going to touch very briefly on some ICAO work that we're doing. The ICAO Assembly is currently meeting in Montreal, and thankfully, we're reverting to more face-to-face meetings, just like we are here. And the ICAO work is also coming back to more time in Montreal, but also having the benefit of hybrid meetings like this. I don't mind spruiking the personnel training and licensing panel. I do that because I'm the chair of it, so I have to take every opportunity to promote it. But it's an exciting area, and I'll just touch on a few points in a moment about what that is doing. Electronic personnel license is a new initiative that starts on the 3rd of November formally, and Annex 1 it comes into force. The EPL is the beginning of the move to electronic documentation, particularly across borders. For most of us here, it's not, well, in terms of Australia, it's not hugely critical because most pilots don't go offshore or don't go to another state. But what it does mean is there needs to be a system of verification and authentication, and that is extremely challenging. As I'm sure you're all aware of the current matter on personnel data integrity, one of the challenges that has faced the ICAO team and the people who are on the working group for the EPL is how to adequately authenticate a person's license on their phone when they rock up at a foreign airport and the local inspector says, "Can you show me your license, please?" And just what does that mean when someone turns their phone around and says, "Here it is"? Anyway, I'm happy to say that Australia is leading the way. Australia, China and Brazil are the three countries that have got the core capability, and I think it's true to say that between China and Australia will probably be the two countries that lead the charge in that, and that's pretty exciting. So on the panel's work, there are 4 working groups, and I'm only going to touch very briefly on these. It's really just a plug. The first one, which I think you should be interested in, which is automation dependency. The ICAO Council and the Air Navigation Commission have been concerned for some time about some of the accidents and incidents in and around this topic of automation dependency. And they've got a lot of work going on at the moment and looking at just what might ICAO do to rectify some of the issues arising from this particular topic. The second one, which is the biggest of all of the groups, is competency-based training and assessment. And for those who don't know, there's a PANS document, PANS training, that sits aside Annex 1, and that has recently been amended and has very significant change implications. Australia has had a competency model in place for about 30 years. I guess it's true in the rest of the world, the multi-crew pilot license is the other area that has got itself aligned into a CBTA model. Air traffic control licensing has, and maintenance personnel licensing has to some degree. PANS training takes it a whole step further. And I really want to engage with industry here to embrace what is in PANS training and find a pathway for us to fully implement it. But there are some very significant implications, I think, for training organisations, for the regulator, and for individuals for that matter, and users. Group 3 is simulation. I haven't said flight simulation for a very important reason. The simulation industry is very aware and developing more and more in other domains. And so whether it's air traffic control, whether it's specialist role personnel in medical transport or other special operations, air traffic control and maintenance, this particular working group is looking at how does simulation get evolved. I think it's easy enough to see that those first 1, 2, 3 groups are connected, because they're all about person, capability, training, evaluation, and the devices or things that we use. And I'd go one step further to say that those 3 things are very much within the domain of this group. You can see UPRT in each of those, I think, if I'm not mistaken. That's why it's relevant. The 4th group is, it is not called diversity and inclusion. It's called, unfortunately, in my view, and certainly to the concern of some of the people on the working group, women, other ethnic and minority groups. And it's got that title because of the difficulties that perhaps some people within the ICAO system have to deal with social topics. What it's trying to do comes from 2 fronts. The first one is, and for many, many years, we've been talking about the shortage of professional people available to fill spots, whether it be maintenance personnel, whether it be air traffic or piloting. there's a large cohort within the community who for various reasons don't access or don't have access to opportunities in the aviation system. So what this group is doing is looking at what might those barriers be and what can we do about changing them. You just look at the group we've got here today and you'll see, and we all know it, we have a very huge bias or biases within our aviation system, and we need to fix it. So this is one of the initiatives on that. So I mentioned New Horizons. For CBTA, the adapted competency model, which is the point I referred to earlier about the changes in PANS training. The model comes from the competencies that were developed for EBT. You may or may not be familiar with those, but they become the standard competencies for pilot qualifications, along with their observable behaviours. This model means that we need to translate what we currently have in our Part 61 Manual of Standards to work out what statements we would have in our competency model for the licenses, ratings, endorsements that we have. There's a strong push to minimise the level or degree of adaptation. Adaptation is about taking a generic model, a generic competency statement and adapting it to a particular context. The particular context is taken from the end user context. So operator, aviation Australia, let's say, I wanted to choose a particular one, maybe Biggles might be a better one, has a need for pilots, and they then, through a training specification or training needs analysis, work out what it is that they need. And within reasonable constraints, adapt the competency standard and the observable behaviours to fit that outcome. That puts a lot of onus on the training provider in terms of development, and it puts a lot of onus on the regulator to try and regularise or standardise those training outcomes. We need to look at this and see how on earth we're going to embrace it. I think that the other part, which is not spoken very much about, but it's connecting the elements of the training equation, whether it's the individuals and where they're coming into the program, whether it's the resources or the systems that the training operator provides, and the end user. All of those things need to be connected well in order to work adequately with this new model. Anyway, we've got to implement it and we need to get on with it. And so I'll be reaching out to you in the near future to come together and talk about how Australia fully implements PANS training. We know that we're confronting emergency technologies, and again, it's relevant in this context. People are talking about things happening in cockpits, whether they're crewed or not crewed, whether they're ground-based, partially ground-based, automation, virtual reality, and all those things. CASA is doing a lot of work on this future technologies area. We've embraced it. We've got a good feel for what we need to do, and I'm sure you'll be hearing more from CASA over the next months and years on developments in the emerging technologies area. I think we've got to be careful that we don't just look at these technologies as being in the non-crewed space. There is a strong tendency, so that's drone stuff. It's not regular operation stuff. I beg to differ on that. I think that emerging technologies are playing an increasingly important, critical, and challenging role in day-to-day operations, the things that we do. Just to touch base on the UPRT journey I mentioned earlier, and people have already mentioned where we've come from, so I won't dwell at all on this other than to acknowledge the extent of work that has gone on, both with people who are online, thank you very much, and to those here in the room. I'd like to acknowledge the work that John has done. It's tireless. It's I think it's frustrating at times, John. It's niche. It's specialised. Doesn't always get the resources that it might otherwise seek. But I do acknowledge the commitment and energy that John and others bring to the table. So thank you. And also to Darren. I mean, Darren, for those who don't know, works very much with John to build up some of the materials support and other things that we use that are vital. Without those things, telling stories and getting making progress is impossible. So Darren, really appreciate the work you do. I'd also like to acknowledge Quentin Fuller. For those who know, Quentin is our backbone as far as doing simulator certification. Quentin's not very well, and he's unable to be with us today. So just like to pass on from you, I think, if you don't mind me saying, best wishes to Quentin to get fit and better. He's been involved and others. We've now got 19 of our 32 flight simulators up and running on to the standards for UPRT, and that's really a major achievement. And can I say that work has occurred because industry and operators want to do it. Not really because of what we're saying needs to be done. It's because there's a recognition that it's a good thing to do. And I think that's also a measure of the goodwill that we've had amongst the team in getting the progress that we've made with UPRT. And I think it's a standout success and continues to be. So I'm looking forward to the work that we have ahead of us today. I just want to just make a couple of very quick points on what our posture is on UPRT. I see it very much as focusing on larger aeroplanes in terms of the formalities of it. But we need to take a measured approach to extending it outwards and downwards, particularly downwards. I think we can say hand on heart that training standards in Australia are generally good. Definitely we can always improve and we should improve. But internationally, we are held in high regard. So let's build on what we've got in a sensible, practical and achievable way. And if I could just say, let's not overcook the goose when it comes to implementing change in our licensing system and our recurrent training at the lower end. As I said before, we've got a challenge in CBTA and PANS training that's going to challenge us. And I think that this particular element is one part of that. So to close out, I just want to say, can we please keep the engagement active, effective? We do collaborate well. I think this particular program is a very good example of how well we can do it. We don't always do it as well as this, but I think we generally do. Oops, a little spelling mistake there. Your input into the ICAO work is very much appreciated and welcomed. As I say, we'll be ramping up the interactions in the coming months. Thank you very much for your attendance. Thank you to those overseas, especially those at the back of the clock. I know very well the challenge of online meetings. Just to put it into context, tonight at about 11 o'clock, I think, 11 p.m, I have a panel leadership team meeting. So thanks for coming online. Enjoy the day and appreciate your attendance and contribution. Thank you.
Thank you very much, Roger. Okay, just bear with me for a little bit while I get up the next presentation.
Hey Darren, it's Darren. We've got no audio online.
Hey Darren, have you got me now?
5x5, mate.
Okay, moving on. Thanks. Glad that someone understands how all the technology works. We engage in various industry and regulatory simulation networks, of which there's quite a few, and moving more into giving advice for a better approach in line with CASA's focus on GA to the lower level training devices, including FSD2 that we just talked about. And basically going to our core issue, which is that FSTDs don't have an end in themselves. They're there for training, and they need to meet the simulation feature and fidelity levels that support the training, and that we oversight them in a consistent way. Under the Act, we are required to develop and promulgate standards, develop compliance strategies, do the things that ICAO requires in Annex 19 of a regulatory authority, such as issuing licenses, conducting surveillance. That's a work in progress in the simulation space, and regular reviews of everything we do. And we try and have those in Flight Standards Branch, get-togethers online, obviously during COVID, but get-togethers where basically we all say to each other, how's it going? Are there things we need to look at again? Things we need to revisit. Just to reiterate the work on loss of control in flight, and it's a privilege to have Sanju Advani online and to have a good relationship with our colleague Jeff Schroeder from the FAA as well. People who were at the very toppest of top tables when all of this was put together at the Royal Aeronautical Society and in other forums. That work has a long gestation period, and we should all remember the folks that started in committee rooms long ago to put it together. Our journey formally started in 2014, but of course we were well across through the sorts of panels that a lot of CASA people take part in out of ours. We were well aware of what was coming and looking forward to it. In November 2014, the long-awaited changes to Annexes 1 and 6 came out, and they made mandated type rating essentially for the Part 121 world. ICAO also recommended in Annex 1 the training in UPRT for the commercial pilot license in addition to type rating MPL and ATPL. We've been, as I said, we've been following it for a number of years, and we're ready to get on board with the rest of the world when that came to be in November, I think, of 2014. We approach those as CASA does with all the new developments that come out. We spend a fair bit of time tracking these things, looking at our obligations under the Act, thinking through, and this is where Roger started to do what we call a stock take of where we sat relating to those changes, to think about what resources we'd need, how we'd train our FOIs, looking at the ICAO SARPs and what other NAAs were doing. Remembering that 2014 was very much at the beginning, a lot of this stuff, even some of the simulator upgrade packages weren't even built then. We knew from the very start that we would want high levels of engagement with SMEs from around the world and our own industry. I like to think that in the last 5 or 6 years, we've lived up to that. COVID has made it difficult, but I think we've lived up to that high level of engagement, and your presence here today and online, and thanks for those who've travelled, is proof of that. We've been also looked at the development of regulations and guidance, including the required UPRT syllabus, which is spelled out in the advisory circular, and looking at competency-based training standards, because as we know, the best use we can get out of UPRT when it's a competency-based training activity, not proficiency check. We've also spent some time looking at the training media options. In our case, the biggest focus was in the Part 121 world on flight simulators. We had a look at what sort of simulators and what we might want in terms of their upgrade. So those of you familiar with the Manual of Standards for Part 60 will find there, it's quite a short document. It describes exactly what we want in devices and by what timeframes. So there are some deadlines in that which relate to the bringing in or the upgrading of existing simulators just for extended envelope training. If you're not sure about how those work, and there may be one or two, I think, who are in that world, please get in touch with ASAP so we can be clear about the path ahead to upgrade your devices. And then we have looked, as we're required to, and EASA and the FAA have both looked at this, the cost benefit of additional mandated training. Everything we do, once you translate it into 50,000 airline pilots, starts to become a burden of cost. And the world in which we could just say, well, that's safety, doesn't cut it anymore. We actually have to demonstrate why and how we would want to do it. Just to be clear on some of our terminology, for those who aren't that familiar with it, Part 61, our licensing regulations, spells out the definitions that a flight simulation training device, which is probably what Part 60 will end up being called one day, is a qualified flight simulator, and it only relates to qualified. If it's not qualified, it's just a box. We don't regulate boxes. It's got to be qualified. Qualified flight training device, synthetic trainer, a 61045 legislative instrument. We used that for the first time when we brought out the standards for MCC training, and now we've just brought it out for the head of power for FSD2 and its new versions. And devices qualified by the NAA of recognised foreign states. We've, in the last year or so, added Japan and Singapore to that list, and we're developing a process by which it'll become easier to get the sort of countries where some of you folks will need training done on that list. The role of simulation, again, for those who may not be as familiar with it as some of us are, some of it's pretty straightforward. It just provides more in-depth training and safer training. We can certainly do non-normal training with much higher safety. And you'd be well aware that after a series of dreadful accidents and near accidents around 2008, 9, 10, CASA brought in notice of proposed rulemaking and got comment from industry, and we eventually mandated simulator training under certain requirements that you'll see in the regulations. Essentially, for airline standard aircraft, you have to, if there's a simulator available anywhere in the world, you have to use it. So that's taken us one step further forward, and there's been a great benefit in that. The fidelity of modern devices, far higher than what I would have ever learned to fly on back in the day. And I think it's important to state that simulation is no longer just restricted to airlines. Some of the stuff we get queries about nearly every day that are coming out, I mean, in every respect, probably into the future, capable of being looked at for type rating training and other things. We've got a number of case studies right now within Flight Standards Branch where we're starting to look at capabilities of advanced twin turboprop trainers for standards beyond just instrument rating training. That's very exciting, I think, and we definitely have a heart for trying to get as much training into those things as possible, both to save money but also for the safety effect. And fuel conservation and environment are, there's no doubt, they're key benefits. We don't want people boring holes in the sky the way we used to back in the day, taking a 727 around at Avalon for 5 hours just to get your type rating. It was a lot of fun, but really not the best for carbon dioxide. Some of you will have seen this picture, but the first, I've actually seen one of these, an antique at Shuttleworth on a nice windy day, and it actually worked quite well. We've come a long way from that, but it wasn't a bad thing. In fact, that was actually closer to fidelity than we get today, because it was actually a glider that could fly in actual wind. Then the link trainers. I just stopped in recently at the old RAAF base at Nil on my way to Adelaide, and I had a look. They've got one beautifully set up, and I think it was one I did part of my instrument rating in. There's another one at Ansett in the lobby down at Garden Drive in Tullamarine. Very advanced, and they made thousands of them. My school, Air Training Corps, had one. Now we come to dates where we look at flight simulators, training devices. They're both Part 60, and then the synthetic training devices. And if you were to ask why they're these three categories, it's because that's the way history developed. There was a time when simulators were simply seen as not aeroplanes, hence the word synthetic. And now we've come up with some divides. The work that EASA is doing, and we're very close to, the work that EASA is doing is going to slowly remove those and define devices by their capability, not by what heading they come under. And that will be to the benefit of industry. So when Annex 1 and 6 refer to flight simulation, they basically refer to document 9625, which provides the guidance on the flight simulation training devices. And they are notes to both the UPRT prescriptions in Annexes 1 and 6. Just says, simply note, when we refer to flight simulation, refer to that document. Now, that was amended in 2014 when the Annexes 1 and 6 amendments for UPRT came in, and it has all the detail required for UPRT in flight simulation training devices. And the philosophy is, as I said before, it's that the device must support the training. When we had our first engagement at the SME level, which was with Sunju, came out to Australia, we had quite a big gathering at the Ansett Training Centre at Melbourne, which was seminal in getting our heads pointing in the right direction. The point that Sunju, one of the points that Sunju made that got us moving down this path was that the devices currently, as they existed, were quite capable of doing a lot of training, and that you shouldn't wait for the best possible simulators to get some parts of your syllabus done. And the chilling realization that came to me from the first time we started looking at this in depth was when Sunju pointed out that the pilots in the Colgan accident and the Air France accident, which changed everybody or got everybody's attention on UPRT, the pilots didn't die because the simulators weren't good enough. The simulators actually could have given them the training they needed. It wasn't that. That's something for us all to remember when we start, letting the perfect be the enemy of the good. But even the best civil simulators only represent motion, and they can't yet replicate the aircraft. And that's why in a minute we'll talk about very briefly the concept of correct trend and magnitude, which is really all we want, because someone pointed out to me the other day, in a fleet like Southwest Airlines 737 fleet, which might be 600 aeroplanes or more, the differences between aeroplanes, some 30 years old, some brand new, can be quite significant. And Peter Island will talk in a minute about installing those aircraft and how they can be all different versus the FAR 25 certification trials that they might have gone through. Just quickly look at the simulation advances in general aviation in support of CASA's general aviation push. There's been a big paradigm shift. The growing use, as you're all aware, when 2017 came in, we mandated GPS as a basic navigation training aid. And with that went a very significant reduction in the number of training aids around Australia, making it difficult, especially for the flying schools that had contracts that required Chinese pilots to do actual NDB letdowns in the aeroplane. Life started to get difficult. We think that the properly qualified FSTDs in general aviation can help with that, reduce the burden and add to realism. There's no doubt that some of the feedback I've got from Embry-Riddle has been putting in virtual reality, including weather conditions and the simulated air traffic control is giving pilots a big step forward to being prepared for their first solo. And we offer training scenarios that are not possible on aircraft activity. Of course, there's a reduction in training costs and some training scenarios that go well beyond simple IFR training. As I mentioned before, that's what we're looking at now with a couple of trials to see how far we can take advanced turboprop training in devices that suit certain training elements. They won't support everything, and if there's no motion, they're never going to support, at least in my lifetime, they're never going to support things like engine out, missed approach, engine failure on takeoff, but they can do a lot of things. The highest fidelity in simulators, called full flight simulator, they basically replicate as much as is possible except for the motion of what you'd see in an aeroplane. Mostly now we look at level D. With brand new aeroplanes, we can get level C or interim level C, but we've adapted our MOS 2-3 years ago. We took out a lot of verbiage where we had our own standards and instead referred to the FAA, EASA and ICAO standards for level D and upset recovery training. So when your friends at a barbecue say, why doesn't CASA do what the rest of the world's doing? We are actually capable, and we do listen to what the rest of the world's doing and take the best of breed on board. Flight training devices are very good. And level 7, I'm not sure whether any of you have experience of level 7, Mike. You might have seen some in Seattle. Yeah, very, very good. All but motion. They still won't give you credit, excuse me, for proficiency checks, but they will take the level of training right up there to have pilots who are extremely proficient once they do get into the full flight simulator. This is the document. I'll just, to finish off the FSD2 stuff, it's going to be FSD2 version 2, and that's with our lawyers right now to get lawyerized and published as soon as possible. You'll have I think it will have an opportunity for public comment. I'm not sure that that's been decided yet, has it, Roger? Yeah. There's been a lot of engagement with industry, at a discussion level already. Now, for UPRT, the basic document 10011 was published again in 2014. That was a seminal year for UPRT. It's not a huge document. It's well worth getting and reading. It has pretty much covers everything. And the folks such as Sanju and Jeff Schroeder and others that sat around tables to put this together did a great job. It really does cover where the rubber meets the road for this sort of training. So it's well worth getting your hands on that and having a look through it. Emphasis, obviously, as is always the case, instructor training is critical. There's no doubt at all that when we first sat down and listened to people telling us where to look, the first thing was look at the instructor training, benchmark your instructors. Things like minimizing height loss during the stall, which were taught to some of us. I remember on the 777 at max landing weight being at 15,000 feet, close the throttles till we got the stall and then just open it. And with 230,000 pounds of thrust on an aeroplane only weighing about 500,000, it was like a fighter. It just excited. Well, that's not how people die, unfortunately. They die in other ways. So that sort of approach to instruction, which might make an individual instructor feel good and say, I'll show you what I've learned, that's not what we want, clearly. And we have looked at the industry approach to standardization of instructors, and that's been, I think, a great journey all by itself. Now, with that came IATA. I hope you're all familiar with it. If you're not, it's easy to find. It's free. The second edition came out, I think, 2008. The third edition was published in 2017. You need to really read the second and third edition together. They don't quite overlap completely. There's an app you can get at the App Store on IATA that pilots can use to sort of for home study. A great document, and it goes through the training scenarios, discusses a lot of the stuff like icing. There was a time when the only way a simulator replicated icing was to add weight. Well, you can add 10-tonne of weight to a 747, it doesn't actually do very much. But 10 tonne of ice actually added to the wing, well, you know, I think that's enough to destroy the aeroplane just because it won't fly anymore. So the AERTA starts to discuss, from your pilot's point of view, just what that icing does to the airframe in terms of destroying lift on the wing and many other bits and pieces. So this is well worth having on your bedside bookshelf. Finally, in 2020, just in time for COVID, we published the advisory circular, which from our point of view took CASA down the path of looking at the implementation largely into the Part 121 world, though we did note that it should be of interest to other people. We followed the FAA's Directive 2, which actually came into their public law, or because of their public law change. We took that on board, which basically required training to let you avoid a stall or an unusual situation, a jet upset, or if you couldn't avoid it, how to recover from it. And they are the stipulations. And they are also required to be demonstrated in and out of icing conditions. So there was quite a giant paradigm shift, not apparent to the public, but certainly to us. But the issue of prevention and of awareness and recognition, as Sanju pointed out from the very start, can be done in existing simulators. So no one, even today, needs to wait to start their program if they've got existing simulators for the upgrades that add a level of training beyond the initial stall indication angle of attack, as defined in FAR 25, which could include the stick pusher. We have said exactly what everyone else says, which is we need a level of correct trend and magnitude fidelity beyond, into the 10 degrees beyond that initial stall indication. And that's because, quite simply, life has demonstrated that's where pilots will take it. They'll overpower a stick pusher, inadvertently discontinue the trajectory of a nose rising. Some aircraft like the Fokker 100 have a natural tendency for the nose to rise at an increasing rate. So if it's overpowered by the pilot, you can easily get well beyond that stall indication angle of attack. So we've taken all that on board and put it into this document. So everything we talk about today, and when you go home from here, I'd like you to have a very strong focus on useful amendments to this document, lessons learned, especially we'll be interested in looking at the movement into business as usual in Part 121 activity and anything else for that matter. More than happy to take these things on board. We value the consultation that got us to where we were, and we'd love to take it to the next step ahead. Yeah, just to thank you to the wide array of people that are on board, and we thank you for attention. And we do look forward to your endeavours, including the updating the guidance material, and most importantly of all, to the elimination of loss of control events. We have, first of all, I've been talking for a bit, so I'd like to answer any questions. Yep.
How far away do you think translation of 121.03 content is to a 61 MOS or a 121 MOS?
Look, it's on our to-do list. Roger might answer it as well, but it's on our to-do list. We did do a benchmarking of the columns in Chapter 3 of the ICAO 1011 against every single, I made up a PDF file of the entire manual of standards and listed every single item that's required to be taught, and almost all of them are taught somewhere in the syllabus that gets you to an ATPL. There's not much gap at all, except that which can be done in an extended envelope training simulator. So that's not enough by itself, but exactly what CASA does next. Roger, you might want to comment on that. It's on our to-do list, I think, is probably what we can.
Thanks, Rob. I think I need to get a bit more detail to your question, because I don't have an answer. I'm sure it is, but I would like to get clarity on the numbers. That's okay.
Yeah, happy to talk about that, but we've certainly done a lot of work to see is there a gap. Had there been a big gap, we we would have acted earlier, but happy to talk about that more. Yeah, there's no doubt that guidance material, which we're required to produce, is the glue that takes us between the written black letter regulation and the working arrangements. But
Now I think I've got the connection, Rob. So just to perhaps add clarity, the competency standards, what's in the current Part 61 MOS, as I think we all recognise, have been in place for a long time, and they need refreshing and modernising. I don't think there's any dispute about that. We're very aware of it, and I think collectively we're very aware of it. It's not a project right now, but it needs to be, and I would suggest that we need to connect that piece of work with that other piece of work which I mentioned, which is how do we implement PANS training, because I don't think it's helpful to do that piece of work twice. There are some things which I think Rod's alluding to, which don't reflect current technology or even emerging technology in terms of requirements that we're asking in training and flight testing. So it's absolutely that is a piece of work that's ongoing right now. I can assure you of that. Just a simple example would be, how do we deal with failure of instrumentation? The standards are probably reflect clocks and dials, and so we need to work on that. I hope that helps.
Sorry, any more questions? Anyone online got a question? Okay, so I'll close that now. Just want to reiterate that the task of in budget constrained times of over the last 5 or 6 years, CASA allocating the resources to be able to do all the things we want to do hasn't been little. It's been quite a big task, and we will continue to refresh ourselves in our capabilities as we have moved this into a business as usual activity, as my colleague Wayne Burns will talk about in a minute. So we're a tiny bit behind, but I thought it'd be useful for us to get a perspective of someone who's done a lot of stalls on aircraft stalls in heavy air transport aircraft, which most of us haven't done. I doubt that many of us have taken a stall beyond the initial recognition and recovery. That's something that test pilots obviously do, but we don't normally do. So is Peter's presentation there? So my colleague Peter Ireland, Peter and I work together at Korean Air and a number of other areas in looking at some of this stuff, but Peter brings that perspective. So I'm sorry, Pete, we don't have vast amounts of time, but if you can get started, we'll look forward to it. Thank you.
While we're waiting for this to load, again, I'm Peter Ireland, Captain Ireland, ex-New Zealand Air Force, Australian Air Force, Qantas, long time back, Korean Airlines, Turkish Airlines, Jet Airways. I'm a former JAR, TRI, SFI on the 777, various others. I've done a lot of various aircraft types on training on the aircraft, which is just the way the world is when you go into strange aircraft types. But we're still running into issues there. Hey, this is still loading. Sorry about that. During the various turns and differences in my career, I've had the opportunity to do a fair bit of research flight test, particularly on fundamental aerodynamics and certification on helicopters and also jet aircraft. The jet aircraft testing included basically the full envelope of the aircraft, and the one aircraft that I did it in most recently was the 737. The basic takeaway from that is that the aeroplanes fundamentally fly like an aeroplane does. There's not that much in the way of curiosities as to what the aeroplane does if they were actually certified correctly. Yet the aircraft still has anomalies. The airplanes that we've got in various from various manufacturers at the moment have parts of the envelope that basically they really get close to the boundaries of being acceptable or not. If you have a look at your speed tape of the just hold on a moment. You want to try my computer instead for this? Yeah. Yeah. The slides do have information that's is pertinent to the topic. We'll go with the change of the schedule to actually meet that.
G'day everybody, thanks for bearing with us. Morning tea has arrived, so it's probably a good point in time anyway. First break of the day, so we're going to break for 15 minutes. It'll probably take that long for that to open when we come back. So thanks for your patience, and morning tea should be just outside. Thanks everyone. Thanks Peter. G'day everyone online. We're just going to take a 15-minute break. Okay, so if you want to get up, stretch your legs. We will be back at about 10:45 Australian Eastern Daylight Time. I'll just put it in the chat, and just as a bit of a reminder for us. So see you soon, everybody. Thank you. Hello, everyone. If we could take our seats, that'd be great. Everyone online, thanks for your patience. Sorry, we're a bit late coming back. It's okay if you did you want the, I can put the camera there or there. Which side would you like to stand on? Okay. And if we're all here, this is 2.0 on this one. Apologise for the start before. Upset. What we're looking here is the difference between the real aircraft and simulation, just the minor differences. We're also going to go off on a tangent and cover a couple of minor differences, which then goes from the aircraft, the heavy aircraft upset versus the light aircraft training. And so as we go into this immediately, you'll see that I definitely am a form of diversity because I cover all of these areas and I believe in the whole lot. This is a Layer 24 737, their classic. The Layer 24 experimental category, the 737 experimental category. Layers, the small layers, they stall, they handle just like a normal aircraft, as long as you don't hold them in the stall for an excessive period of time. That will spoil a day, and you'll learn that you need to use ailerons fairly quickly and your rudder very judiciously. Rudders are always judicious. 737, old classic, whatever, and that immediately indicates the problems of old aircraft. A brand new aircraft, as was just being discussed before, coming off the production line, they almost always have the same characteristics. They will stall the same. If they have a coming out of the manufacturing, their specifications are tight. This particular airplane here, we took up to M dive a number of occasions. I wouldn't recommend that with old aircraft ordinarily. And there was certainly other classics that we were flying at the same time that basically wouldn't even get up to MMO without absolutely concerning the heck out of us. The tolerances on things like aileron PCUs and such like, once they start going out, one particular aircraft, November 463 Alpha Charlie, we had it at 0.782. Basically, we had limit cycle oscillation on the ailerons. Really interesting to actually see your wings vibrating at the same rate as the ailerons are dancing in front of you on the yoke. This particular airplane here had gone through, we'd brought it back to normal, and basically that was up to 0.88 Mach, which I don't recommend doing on a 737, but basically no vibration on the ailerons at all. There are big differences on how the aircrafts are maintained. In flight with it, as far as light aircraft simulators or whatever, before doing the stalls on this particular aircraft here, the 737, we would do training in the SOCO there, SOCO Galeb, and essentially get comfortable with what we were about to do. And that was doing advanced handling issues. The T-28 teaches people about using trims, which seems to still be a problem, particularly if you look at the Airbus aircraft, the failures that have happened on almost all of the Airbuses. As soon as they go into a degrade of the modes, the pilots, because of the stress levels they go into, basically forget about the trim wheel in the center. And after that, it's all over bar the shouting. XL 888 Tango is probably the epitome of when these things go bad. It also says anytime you're playing around with a large aircraft and you go doing a test program, be really careful about following the test cards that you've got. As soon as you go outside of that, basically you're on your own. Equally, with that, the test cards give you an indication of when suddenly things are changing. If you're not following that, basically it's time to stop and have a cup of coffee, go out. The aircraft, the majority of the upsets that happen in the aviation community still are perfectly serviceable airplanes all the time through to impact. This one here is Alaskan 261.
261, of course, was one of the exceptions. There are actually a multiple number of exceptions. You can take them United Air 232, United 585, arguably, US Air 427, various others, that basically the aircraft failure causes the guys to get into a upset. The upset, though, with those aircraft will bring us to a particular point. We actually teach on aircraft like the 737, the crossover speed issues of when the aileron authority crosses over to the rudder authority. Fundamentally, that's a misconception. It is a crossover angle of attack. It's got nothing to do with speed. It is angle of attack. And that is why when you have aircraft that are accelerating rapidly towards the ground, and they still have no ability to roll the aircraft because of the hard over of the rudder. It's not because they've now got 300 or 400 knots on the airspeed indicator. It's still because the angle of attack is such, the rudder is taking over control over the ailerons. So only take home from this today, basically, can we start talking about crossover angle of attack, not crossover speed? Situational awareness is our fundamental failure of almost all the other aircraft. The crews get into an area where they get a sudden surprise, cognitive capabilities go out the window, and we're out the door thereafter. Flight controls haven't changed that much. This one is actually an exception. This actually had warping of the wings, so it was slightly different. But every other aircraft we've got has the same sort of flight control systems, and associated with that, the general stability of the aircraft, unless something's come off your airplane, the aircraft is going to behave in a characteristic manner. And it doesn't matter if it's an Airbus or Boeing or a Bombardier or whatever. Essentially, without another failure, it's going to behave the same way. Yet the flight crew continuously drive the airplanes into the ground with their inputs. This is the flow path of the control laws of the right flyer. It's also for a P-51 or whatever, or any other aircraft, a normal aircraft. That's what the drivers are doing to a conventional airplane, Cessna 150. This is a change, and this one here is essentially a C-star function with a crossover based on speed. Airbus, arguably Embraer, in part of their systems, goes this way. This one here is actually the logic system of the Airbus. That's how it functions. It's got a shaping moment in there that changes the output. That's the only difference between that and the other standard C-star function. Then we get to the Boeing, and the Boeing, you've got C-star plus U, the speed function, and it emulates, because the speed function, it's emulating the right flyer effectively. What you put on the pickles is what the aeroplane's going to try and come to. And again, it's still called a speed function, but it is actually angle of attack. So if you're upside down, it ain't going to do anything without getting rid of the upside down bits. When you go outside of the envelope, basically the fundamental problems between doing training in the aircraft, a Part 23 aircraft, like a decathlon or something similar, and doing the 737, is that the control authorities are massively different. The elevator on the 737, you'll run out of very rapidly if you don't actually have if you're nowhere near the trim position for the trimble horizontal stabilizer. The rudder, obviously, American 587 taught us don't play around with the rudders, because if you go into a bending torsion mode or whatever by alternating your rudder inputs, it will take the tail off the aeroplane. We've seen that on 747s routinely. We've seen it on Airbus A300s quite routinely, and by the grace of God, people haven't actually pulled the tail off the aeroplane. The structure, the controls on the Part 25 aircraft have got the authority to basically tear the back off the aeroplane. And that's the fundamental difference. Most of the light aircraft won't do that, although If you look at a Piper Tomahawk, you'd wonder occasionally. Moment arm from the CFG. When you're in the large transport category aircraft and going outside the envelope and basically the airplane's rolling rapidly or pitching rapidly, the moment arm to the flight crew is significant, and it's one thing that you can't generate in the simulator. It doesn't do a good, very long-term temporal change of that. However, the actual the magnitude of those loads is not that high. Between 0.2 G and 0.5 G is all you actually get additional load because of that. It's not that significant. But the vibration and the buffet is phenomenal. It is a significant difference. Simulators will give good buffet emulation. It's not bad at all. But basically, if you go deep into the buffet, we'll show you a video of the MD-11 tail. Basically, the stall, particularly clean stalls, the buffet on these aircraft is substantial. It's high amplitude, low frequency, high amplitude. Mark buffet, you take you go to M dive for a 7.3 or the MD-80, put on aileron, pull G, 2G. Effectively, at that stage, the amplitude of the Mark buffet is considerable. The frequency is actually much higher. It is a different frequency to the low-speed buffet, yet effectively, we seem to have issues modeling that. Inertial moments. Basically, all of your large transport category aircraft, in comparison to doing training in your Part 23 aircraft, like the Extra is great for what it does. And as I understand, you guys are limiting the control input, so your amplitude of your control deflections is actually reduced. That's great because the control authority that you're going to get in roll, particularly on any of the large transport category aircraft, is going to be significantly less. Equally, the roll inertia, once you start going, particularly at a high altitude upset, if you roll, because you've got low density altitudes at 45,000 feet or whatever, the actual roll inertia basically speaks against being wild and exciting in the amount of bank angle you put on to recover from a high nose attitude, because you're not going to pick it. The airplane will not respond rapidly. Vibration amplitude, we've spoken about that. The majority of the error models that we have in the simulators are actually darn good nowadays. They're really good. They haven't always been. One of the accidents that I was involved with the investigation of involved basically a loss of control of the aircraft at low altitude. We actually went and did sim validation of the certified sim under the FAA for that particular airplane, and found you could fully stall that aircraft and it would climb at 6,000 feet a minute. I would contend that's probably not correct. At the same time, there was another sim, and I'll show you an image shortly, of that was being operated. Beautiful model. Error model was actually exceptional, been upgraded, and it was darn good. It had good inertial cross-coupling effects in it. It was a thing of beauty. The airline involved was doing microburst training, and they went to a model where they entered off axis. So it wasn't axisymmetrical, it was going glancing past the downflow. And pretty much every time they did that, they would end up with a spin out of that. It would auto-rotate every single time. They attempted to ground the model, and I looked at it and went, actually, that's exactly what the airplane will do. If you have a look at what the controls are of that, if you're pulling through to stall and you've got a high yaw rate on, this is what you're going to get. It's not going to be anything different. The degree of freedom that you've got in a simulator, the variations, essentially, they are a practical consideration insofar as they are not an exact emulation of the real world. But from doing them in the aircraft, I can say that I don't believe personally that it's actually a significant factor. That the long period of G loading that you would actually put on the aircraft, the longitudinal acceleration that you get if you have the misfortune of going into auto rotation is actually, whilst it's there in the real aeroplane, is not actually going to be a factor that should affect the training value you've got of the immediate actions of a simulator. The real world is going to be different. It's far more entertaining. This is a model of the downwash or the microburst. And if you go into that and you're not absolutely pointing the center, your airplane, if you do the normal procedures, pretty much you've got a damn high probability of actually spinning the aircraft out. That's what a real airplane will do. Simulators may or may not do that. Normal stalls, the majority of simulators actually do a pretty good job when you get up to a normal stall. They're not that much different to the aircraft. And the aircraft that I can talk to are the 737s, Learjets, Falcons, Westwinds, and MD-80s, 82s, 83s, etc. In all of those, the real stall, the anomaly that you'll see in the real world that you don't normally see in the earlier models of the aerosims aero models is that if you've got an auto slat system, if the aeroplane is not been in maintenance recently or not been kept particularly well, you'll actually end up with a roll off as you approach the stall as often as not. That's because the slats extend on almost all of the swept-wing aircraft. The slats will extend outboard to give you a improve aileron control and also your pitching moment improvement for the entering the clean stall. And when that comes out, you'll get a roll. And at that point, you're going to get an interesting issue that you're now going into. If you have a high rate of deceleration, as that happens, the chance of actually getting the airplane to depart rapidly is actually fairly high. So the rate of entry, the standard in the test is 1 knot per second deceleration, which is a pain to actually do, or a 3 knot or greater rate. 3 knots or greater will actually definitely give you a fascinating little roll-off. And as I understand where we've gone now with the simulators recently is that there is a random generated roll-off on a number of the aerosim models. Excellent idea, because that's what the real airplane will do, particularly clean. When it's fully configured, not a factor. So MD-11, the 6,000 feet a minute rate of climb in a fully developed stall just isn't on the cards. Okay, the airplane doesn't do it normally. It's not going to do it when it's fully stalled. Mark Buffett, the simulator gives you an idea when you do this that, particularly in this case for the MD-11, the Mark Buffett, if you go deep into the Buffett boundary, the simulator gives you a reasonable vibration, and it gives you an idea that you're deep into Buffett. That's great. Actual aeroplane, it tears the elevators apart. Well, you had 2 of those that we that investigated, and in both of them, the carbon fiber skins had completely fractured and been torn in torsion. And in both occasions, they were lucky to get the airplane back. The only thing left was the forward vertical spar on the section. The D section in front of that was broken. The sections behind were completely separated, and the mass balance was sitting out there in the breeze, just vibrating. So the Mark Buffett, when you go into overspeed or whatever on these airplanes, that airplane needs to go to maintenance really quickly. It's not to play around with. It needs to be looked at, and particularly the back end of the airplane. When we were testing the 737, after every flight that we stalled, which was quite a few, every single variation in the modifications we were doing, and every baseline we did, we would stall the airplane. That's a normal stall, clean stalls, dirty stalls at 15,000 feet, go through to high altitude stalls up to 37,000 feet and above, and with wind up, accelerated stalls. After every single one of those, we did an inspection of the tail. That's what the AMM calls for. That's what common sense suggests, because the vibration is that significant. If anybody comes back and says, oh, by the way, might want to look at that, do so. Your sim, it's not going to do that, but don't be surprised if you're actually emulating the real buffet levels. If the sim falls off the jacks, it's not an unreasonable outcome. It is quite violent. The different events that have happened. This is a DC-10 event with a loss of control after rotate. This is Delta 1080, and the elevator on the left side jammed when they were doing the flight control checks after engine start. Full left up, and they went around the corner. One of the problems that we have in the industry all around is this was an analysis that was actually looked at and used in prior training of jet upset by American Airlines. They make a comment in there that this airplane got airborne, and because it was pitching nose high, guys rolled off and did reversing turns to avoid losing control of the aircraft. In fact, that's not actually what happened. So occasionally when the information's given to us as to what's happened, it's worthwhile going back to basics and actually ascertaining what's happened. That's become local law. It was still an incredible save, and that was done by thrust management to control the pitch of the aircraft. But the story was different to the reality. So the control authorities, the biggest change between doing the light aircraft and the jet transport condition is that the related to the CFG and the speed range that the jet transport's got, we end up with a trim problem, and that stabilizer is extremely effective. Along with that is generally you've got underslung engines on most of the RPT aircraft. Some of them are higher thrust lines, but basically the thrust line difference is always going to be a significant factor. Light aircraft, extremely good for situational awareness of the guys, but basically a simulator, doesn't matter what level of the qualification the simulator is. Basically, if it can actually show that you can run out of stab, or it shows on an Airbus that basically it's a really good idea to hit the trim wheel, it's not going to be a bad thing. The alternatives to secondary effects of controls, we are still covering that in various areas, and the simulators tend to do that quite well. The delays in thrust or whatever are reasonable and follow quite effectively what the actual aircraft does. So it's not a bad place to be. Altitude loss is mentioned there. Essentially, if you go into a full roll-off and exceed the certification roll limits, you could be looking from a 15,000-foot start. Basically, you can lose 10,000 feet without actually losing too much sleep over that. So when you're playing around with these aircraft at any altitude in the real airplanes, basically having altitude underneath you makes up for having no good ideas. At high altitude in a cruise, the recovery in a cruise stall of an aircraft like a 737 is actually a non-event. Basically, as soon as you start lowering the nose, the airplane will slowly recover its speed, and it will come down. The thrust couples are so, the thrust is so limited by the density that you're dealing with, that essentially you don't have a pitch couple problem ordinarily with whatever you do with the thrust levers. It's not going to do much. In fact, if you're back at idle, it's not going to do anything either. You're still going to level off at about the same point. The recoveries otherwise, even going to high speed stalls of the aircraft at high altitude, in a 60-degree bank turn, the airplanes will actually behave quite well. The requirement is that the airplanes ordinarily stalled at 30 degrees in test, and it's allowed to roll off depending on what your deceleration rate is. 1 knot a second gives you 30 degrees roll off to in the direction you turn, 60 degrees roll off in the opposite direction. That's at 1 knot per second. 3 knots a second. It's 60 degrees in the direction of turn, which will put you to a 90-degree bank angle, and it'll roll up the other side by basically 60 degrees. So it'll actually go past wings level into the opposite turn. That'll take us to a video shortly of what happens when it doesn't do that. The rest not going to bother with here. These are a couple of different incidents, and fundamentally, if we don't do anything else with the upsets, essentially we've got to stop people pulling back on the prong. USA 427, the line there in this dotted line along in here is the elevator. Airplane was never going to recover anyway, not with a full back stick, not going to happen. The roll rate of that aircraft, it's also auto-rotating, and again, it's not going to get anywhere in a hurry. Same again. This here is one of the ones we actually looked at. It was a pretty sad accident, and this was an attitude indicator failure on the pilot's side. They rolled into the ground 90-degree bank roughly, and the rest of the crew were entirely aware of it, but situational awareness, captain didn't know until he had actually, after he was dead, as to what had happened to the aircraft. The simulation, this is the MCAB output, and the validation of that shows what it actually did versus the actual accident. That's there just to indicate that essentially the MCABs give you enough information to actually be able to model aircraft when they get outside of the normal envelope fairly effectively. That's what the guys were looking at. And 2 out of 3 say roll right. They went in 90 degrees left bank. This is essentially a new problem that comes up. Somebody might actually recognize where this is. I'll mention it later. That's what a head-up display looks like when you're having a really bad day. This is a situational awareness problem, physiological, somatographic problem. These guys drove a perfectly serviceable airplane into the ground. And that's what it looks like if you're looking up through the heads up. And I'm not too sure where we are in looking at training where the aircraft has got a heads-up display versus a head-down display. What are we teaching? This is what it looked like when it did its auto clearance of the HUD. That's what it looks like. And this was about 20 seconds before it came to an end. This is the rest of the data on that. Another upset, this aircraft here. We've seen this one before. We saw it with Air France 447. The first input here is by the co-pilot, and he's putting in a right roll, a right full nose up. Right roll's not too bad. The full nose up's got issues. This is where effectively they go in the end. This airplane impacts the ground, basically going vertically downwards with a angle of attack of around 65 degrees. And that's what we do with Airbuses routinely. This is XL 888T, and essentially we've got the exact opposite of that. The modes changed. The guys who lost situational awareness, and basically everything else goes. Putting on the power, we've got the outer trim case, which is the fundamental difference between Part 23 and Part 25 aircraft. When they put the power on and they didn't lower the nose by rolling, effectively this was a preordained outcome unless they got their hands on the stabilizer trim. And that didn't happen. Propeller aircraft, everything's worse essentially, and add tailplane icing. Fundamentally, from my perspective, from the accident investigation, from looking at the simulation and the real aeroplane, without situational awareness, basically, you might as well walk home. That's what the simulators give us the capability of doing. I'd add this point, that it doesn't actually matter how accurately the simulator emulates that particular airframe that you're flying. We can do a simulation of a upset in a 777 or a 767, and it'll actually cover the 737. The A320s, 330s, 340s, 380s, slightly different, but basically anything that actually has a mode that actually degrades to the pilot having to put their hands on a stabilizer trim is a good thing for an Airbus aircraft. But basically it's a situational awareness function. Doesn't have to be perfect, it just has to be adequate. Procedures, the high, nose low, fundamentally, we still basically have, in all cases, people not even going to that area. We have people that are essentially sticking full backstick all the way to impact. There's just not one aeroplane out there that you can actually do that with and survive. It won't happen. The reversionary controls, outside of the scope of this, but basically if we're doing upset, basically when we've got the anomalies, the angle of attack is one of those critical factors because it affects all of these items. If we don't manage the angle of attack, basically we're not going to get yaw and roll working correctly. To control failure in this, that's galloping ghost. Most aircraft, yeah, when you get a control failure like that and pull 10G, it's going to get a pretty bad outcome. You'll get that on a Part 23 aeroplane. Usually you won't get that on a Part 25 aircraft. And yeah, we'll finish at that. Sorry to go on. Take questions if anybody has any desire to do so. I'll just show you the two test videos. We'll start with this one. This is the MD-11. To say how much buffet you can actually get. Run that, please, and go full scale. We can kill the noise. Bottom left. Okay. This is a clean stall, and this is compliant with Part 25. And if you have a look, shortly you'll actually see how much motion there is in the tail engine as it's actually vibrating because of that, of the buffet there. Stall buffet on these aircraft is significant. So after you've done it, go back and actually get the engineers to have a look. It's always worth the effort. That's a clean stall, and that is fully compliant. The roll-off is 20 degrees. This is a dirty stall, and the roll-off is required is 20 degrees. Okay. So this was early on a program. They came back and they said, well, that didn't work, but let's fix that, okay? So they played around with it. When you look at the aircraft on the line, 787 and such like, you'll actually see a whole bunch of stuff that's out on the wings. My favorite stuff, my specialty is vortex generators. They're there to actually stop that stuff happening. Which now show you the last one here. It's the 717. Just bring that up for a second. Go up. No, it's on the top here. Go up. It's already there. We're killing the noise. And pretty much everybody's probably seen this, okay? The guy in the left seat there is Gary D. Smith, Bear Smith. And point of note on this is that it's actually got, well, I'll ask a question. Do they have symmetrical thrust when they go into this? What do they have with the ailerons, and what do they do in the recovery here? So just, yeah, 30-second silence on this one. Gary Smith was a 1972. He was a Blue Angel young lieutenant, having done 300 sorties in Vietnam during the bad days, flying Phantoms. So that particular recovery there, if you have a look, how many people think that that was done with an asymmetric, with an engine back at idle? Anybody? Anybody for asymmetric? Nope. Okay. Why did they get the roll off? Why did that aircraft roll? Sorry? 30-degree roll. The regulations require, and this is a slow one, this is 1 knot per second deceleration, if you have a look at the tapes, okay? So it's 1 knot per second, their roll-off is to the left, it should have been 30 degrees to the left, okay? They went basically inverted with that, okay? So the question is, why did it roll? Okay. One of the requirements under the testing is that the aircraft is, if the manufacturer says that they can have a 2-ton fuel imbalance or whatever, that's what you got to show. So when you go out there, you actually have to do the testing, including all of the imbalance requirements. That's why the aileron there is got right aileron in. The rudder is actually neutral in that one. It's the aileron is in there to make up for the fuel imbalance. So when we're in a simulator doing modeling or whatever, before you actually go and complain to the sim subs that they've got a problem with their model, check what the imbalance was, because that aeroplane will do exactly that if you do it that way. Okay, gets very exciting. The other one in that is that the roll that he got, sky pointer, shows they come down, they go to 65 degrees nose down. They lose 10,300 feet of altitude, and they go past M dive in the recovery. So that aeroplane goes back to the shed for that one. Equally, while they're doing that, the sky pointer is, if we're not teaching anybody anything else, basically the sky pointer position is critical. The other one is that if you're upside down, you've got to start unloading the angle of attack, because the airplane's not going to roll unless you get rid of that angle of attack. If you've got a really slow rolling aircraft, then basically that's a time where you need to either get a little bit of religion or start thinking about a little bit of judicious rudder as you roll through the center. The last part on that is that Bear survived all of that. He survived Vietnam. He survived testing at McDonnell Douglas. He retired. He went flying decathlons out of Arizona and was killed on the 10th of October 2005 with an air turn back at 500 feet in a decathlon, and they spun it into the ground. So when you guys are out there in your light aircraft or whatever, okay, that's the real world. That's what kills you. Okay, the simulator's really good, not killing too many people, but the real airplane will kill you very dead. Any questions?
Great, thanks, John. That was great, thanks, Peter. And it's a good lead into what I'm just going to talk about. I'm going to talk very generically about the on-aircraft and simulator type training, but more so about the actual instructor training and bringing instructors up to speed on what can happen, what can go wrong, and the limitations of the different tools that can be used. First of all, I would just like to thank CASA, Darren, John, Roger for putting this on. This is really great, and it's again following on from the chat that we had up in Caboolture about 6 weeks ago. It's you know, moving the industry along this path really, really well. For those who don't know me, as I mentioned before, I'm the CEO and director of UPRT Australia up at Archerfield. My co-director Jeremy Miller's over there in the corner. So we started UPRT Australia in the middle of the pandemic. Great idea. We thought about starting a cruise line, but we thought, you know, let's start a flying school instead, because that's a surefire way to make money in the middle of a pandemic. I'd also like to just mention that I also do instructing on the 787 simulator for Qantas, and there's a few guys from Qantas over here. I'd like to acknowledge in particular Matt, just hiding around the corner there. Matt was the lead on our UPRT program at Qantas. I have received permission from Qantas Flight Training to talk generically about how simulator training for UPRT happens as well. So I'd just like to acknowledge Qantas Flight Training for letting me talk on that. So leading on, so as John sort of mentioned, it's a fairly unique perspective that I can bring to this, and really what we're just talking about is the limitations of instructor selection and training and syllabus construction around UPRT. One of the big things that we do need to talk about a little bit more, I think, is the, as Peter was alluding to, is the response from the pilots in the unexpected events. And certainly, I'm no expert. I will err to some of the more luminous people in the room, like Pat Murray over here in the corner, who's done a lot of research in this particular area. And just having a talk about some of the responses that we do get. A quick chat about sims versus on aircraft, and particularly about what can go wrong as well if this training is done incorrectly. First of all, just want to talk about buying in. So there is a reluctance within the industry about UPRT. And I think the main reason is that unusual attitudes has been taught for a long time, and stall training is obviously been taught for a long time. UPRT is obviously a combination of that, so we've been doing it for ages, so why do we need to change? So one of the things that I come across quite a bit is pilots who want to say, I've never been close to a loss of control in flight. My immediate comeback to them is, well, how do you know? How do you know how close you have been to the edge of that envelope when the aircraft is about to depart? And really what we're talking about is the use of the Johari window. I'm not sure if people are aware of that, about looking at the things that we don't know about that can happen in an aircraft. And I like to bring this phrase up. It's what we're talking about here is the unknown unknowns. Something that will happen in an aircraft that we haven't been trained specifically for. And how are we actually going to respond to that if we haven't seen it? And the response from pilots is wide and varied as to when they're exposed to an event that they haven't seen before. The responses are very, very interesting, to say the least. These are the events that you cannot armchair fly. So let's talk about instructor selection to start off with. So everyone in here who has had a flying lesson of any description will know that there are pilots who should not be instructors. Okay, same goes essentially for UPRT instructors. UPRT brings in another element of training and another element of threat that is not really suited to a lot of people. Let's be very clear about that. So what do we need from a UPRT instructor? Well, they need to have good knowledge of aerodynamics, good knowledge of non-technical skills, the human factors, the soft skills, the stuff that in aviation generally is found very unsexy. So we need to have people who have a good awareness of that and a good awareness of themselves and their own limitations. So from the aerodynamic perspective, they need to be aware of the platform that they're teaching on and instructing the student to go and fly. A really good, sound aerodynamic level. They also need to be able to break down and explain some misunderstood or misconceptions. Things that are misunderstood. Example, stalling is related to speed. That is still a conception that is out there in the industry. Pilots believe that they stall because they run out of airspeed. It's true to a certain extent, as we know, but it's breaking that, they're going, no, it's not about airspeed, it's about angle of attack, and recognizing that. From the HF, the non-technical skills, the human factor skills, we're looking at decision-making processes, awareness of situational awareness, as Peter was alluding to before, and we're going to talk about that in a little bit more detail, but that is really, really important. And also cognizant of your own limitations and being disciplined enough to operate within those limitations. From a skills perspective, we're looking at, especially when we're talking about on aircraft training, you've got to have extensive all attitude and all envelope experience. You've got to be comfortable with being in any attitude at any sort of energy level. You've got to understand and be responsive to the counterintuitive actions that are required. Okay, unloading the aircraft by pushing the stick forward or at least relaxing the back pressure when you're 85 degrees nose down is not intuitive for a pilot. So you've got to be able to work through that with your trainee. Got to have good communication and interpersonal skills, okay? Goes without saying. It is really important when it comes to upset training because you are starting to push the pilot outside their comfort zone in a very real fashion. Understanding different learning techniques, again, going back to, you know, the way that different adults learn, understanding that, not trying to force your learning style onto other people, again, because otherwise you're not going to get that buy-in, you're not going to get that break-in for the impartment of knowledge. And also you've got to be open to new ideas and ways of instruction. Okay, we're going down a path that really hasn't been done here in Australia in regards to upset training, combining that human factor element into the technical skills. So we're not going to have it right first time. So we've got to be open to new ideas and different ways of doing things. The other thing that will go in there as well is SME selection. So for those who are looking at fleet specific type training, having someone or a couple of people in each fleet who are the subject matter experts, having that overview and making sure that the standardisation is there within the instructors that they've selected. So instructor training, well, what do we have to talk about? Well, when you're actually training the instructors for this, we've got to look at all aspects of aviation knowledge. So when we're looking at loss of control in flight, is it a deficiency in training? Is it an unplanned response despite the training that they've received? Or is it both? So from an instructor perspective, you've got to be able to identify, is it a lack of knowledge? Or is it the fact that they were overcome, they knew what they were doing was wrong, but they did it anyway under the circumstances? We've got to have skills pertinent to the out of control scenarios. So again, we're looking at the loss of control, being comfortable with the aircraft in really unusual attitudes and energy states, good manual handling and recovery skills, an ability to constantly self-reevaluate, reappraise, and look at competency within yourself as well. So benchmarking your performance again against what should be required. Understanding, controlling fear and anxiety in trainees. Now, this is really, really big. One of the things that we find is that there is a really highly instilled fear and anxiety around stalling in pilots of all levels. The reason I think, I'd be happy to hear suggestions from in the room about this as well, is that stalling is not taught well at GF5. It's done by instructors who don't quite understand the concept themselves. They rush the recovery. They don't explain to the student exactly what's going on. They can see that the instructor is anxious because the instructor hasn't been trained, because their instructor wasn't trained properly. And now this puts a lot of anxiety and fear into the student and the trainee when we're talking about stalling. So understanding that fear and that anxiety element in the trainees is really important, and allaying those fears and putting in when we talk about the syllabus construction, constructing the syllabus in such a way that it reduces that fear and anxiety in the pilot so that they're not afraid to stall the aircraft. Because without stalling the aircraft and understanding the aerodynamics of the aircraft beyond the critical angle of attack, we may as well go home now. This leads on to the next one, which is recognising trauma and potential trauma in trainees. If you do this wrong, The learning is going to stop and you're going to scar the pilot. You're going to scar the trainee. I was talking to John outside and he said, you know, a lot of pilots will come and do their GF5 and it was done, you know, in such a way and the pilot would never come back for another lesson after their stalling lesson. Right? You've instilled a level of anxiety and fear and trauma in them. We have had, in our on-aircraft training, we have had responses from pilots which has ranged from complete lock on the controls through to pilots making grown men cry because of their anxiety and their fear. So that needs to be managed really, really carefully because you're not going to be able to impart the knowledge and get them through that barrier and let them understand what's actually going on and get them through to the next phase. And obviously, instructor training requires helping the instructor assess the capabilities of non-technical skills, which again is becoming more and more evident within the industry, which is good. Technical skills are really easy to mark, plus or minus 10 knots, plus or minus 100 feet, plus or minus 10 degrees on heading. They're very black and white. Non-technical skills, often, if you're not trained properly in how to recognise them, it's not evident that they're lacking a non-technical skill until the error is made. So syllabus construction. Spoke briefly early on about Doc 111 UPRT. Okay, first of all, it's got to be appropriate. So what we see in Doc 111 and UPRT is not necessarily totally relevant to an RA Oz pilot. However, the underlying competencies and where the document is driving towards is valid. So it's a making sure that the syllabus content and construction is appropriate. Validating knowledge is really important. Again, we're trying to understand, is there a deficiency of knowledge within the trainee or the pilot before we go any further? We cannot assume that the pilot has the base level of knowledge that we expect them to have. They may have been hiding it for a while and being able to get through their training without actually having that deficiency rear its head. So we've got to find ways to make sure that the deficiency of knowledge is recognised before we start moving too far down the path. Looking at why and not just the what. So what we mean by the why and not just the what. We're looking at the human factors really around the loss of control in flight. Why did the pilot make the decision that they made given the circumstances that they were in? Why can't the aircraft fly efficiently beyond the critical angle of attack? Ask most of the pilots in GA, they'll probably say, what happens at the critical angle of attack? Oh, the aircraft stops flying. The aircraft doesn't stop flying. It doesn't fly real well, but understanding why it happens, what is actually going on beyond the critical angle of attack. Why do different aircraft handle differently when they're stalled? Okay, and what we're looking at with the why is the prevention. That's the prevention part of UPRT. A good blend of aerodynamics, non-technical skills and case studies to tie it all together. Understanding adult learning principles, again, okay. Involving, okay, lectures don't work for adults, as we know. PowerPoints, do as I say, not as I do, by the way. PowerPoint presentations, death by PowerPoint, everybody hates them. When we're talking about UPRT, we've got to look at the first 2 points of Maslow's theory. Okay, we're looking at physiological needs and safety. We're looking at taking pilots outside their comfort zone, taking them outside the envelope that they're not used to being into and will already have an elevated level of anxiety and fear. So we've got to allay those fears and understand that there will be that element of anxiety. We've got to put them in a good physiological place and we've got to back up the safety systems with them. Obviously, the syllabus has got to be constructed with reference to guidance materials. So not just those two, we've got AC21, we've got, 121, we've got the FAA guidance materials, we've got EASA. There's a lot of stuff out there that's really good to underpin the syllabus construction. And obviously, we've got to talk about the surprise events as well. Okay, because that's really what UPRT is. It's a surprise event that that the pilot wasn't expecting to come along. Because if they were expecting it, they probably would have made a better decision. Okay. When we're talking about syllabus as well, got to insert it recurrent. Like any other skill, these skills are perishable. So we've got to understand that just doing it once is not going to fix it. It's not a one-off standalone event. The skills are perishable. So proficiency and competency. Okay, so when we look at the MOS 61, okay, we look at stalls, approach to stalls, unusual attitudes and engine failures. We train to a level of proficiency, a level of competency. We look at that. Okay, but when we go out and we train these, we're looking at training again for the expected event. We go out to assess stalls. The trainee knows that it's coming. The trainee knows that they're going to go out, do a PPL flight test, they're going to have an engine failure. They're ready for it. The problem happens when the unexpected event occurs, and this brings in the startle and surprise element, or really what we're talking about, flight and freeze. So just very briefly, and again, I'll refer the more in-depth questions maybe to some of my learner colleagues over here on my left about startle and surprise with the PhD research that they've done. But very quickly, a lot of you may be familiar with this, but the idea is that we get a stimulus, goes into our sensors, into the brain. We get an initial muscle flinch within 5 milliseconds. Okay, at the same time, that particular event is sent to the amygdala for threat assessment. Okay, and the amygdala will then tell the other part of the brain, the medulla, another part of the brain, to start releasing adrenaline. Okay, the hypothalamus is then also activated from that shot of adrenaline, and that activates the sympathetic nervous system response, the stress response. Pupils dilate, muscles start to tense, ready to ready to fight or run. Okay, we get the body starts producing blood sugars to activate the muscles. That's why people, when they get the shock, they start trembling because of the blood sugars and all that sort of stuff. Okay, the adrenaline will also hit the prefrontal cortex of the brain. It increases our focus, brings it into the imminent threat. Okay, so this is known as the startle effect. Now, 5 milliseconds to flinch, 15 milliseconds for the initial adrenaline shot. Okay, we can't control this. This is going to happen. Understanding that we cannot control the startle response away. The problem is that if the threat is sustained, and the more salient the threat and the higher the threat, the longer this will go on. If they're not taught how to control this, within, depending upon the person, 5 to 8 seconds before you get prefrontal cortex locked down, and it doesn't matter what happens, they're done. So talking about these sorts of events that people don't get trained for, take Air France 447 for an example. One could argue that they didn't crash because of what happened down at 18,000 feet or 15,000 feet, that the fact that they didn't recognise by that stage that the aircraft was stalled, they never got out of the headspace of the startle and surprise event back at 37,000 feet. So we can't control the initial startle, but what happens after the startle we can control, and this is where we get the surprise. Okay, so the subsequent surprise response is what kills pilots. It's the response post-startle. Taking two very different responses, one we've spoken about, Air France 447, and then you got United 232. Very similar in that they were extreme events, but the pilots handled them differently. They got on with the job, they avoided the emotional jet lag, and they got on with it. When the surprise event occurs, we're going to have reduced cognitive ability. Okay, again, we've got to train through that and make the pilot understand what is critical right now. Diagnosing the problem, diagnosing why it's happened is not probably the most important thing right now. Let's get on with it. Let's get the aircraft back under control. We can deal with the why this has happened later. we talk about the what, how, and self. So training pilots in the surprise response, understanding what it is, how it's going to affect them, how it can adversely affect them. And one of the things that we train quite hard is recognizing the surprise response and the emotional and physiological feeling within the individual pilot, so that when they can start to feel that response in themselves, that it's almost like a self-recognition that, okay, I need to take a step back from the precipice right now, because if I don't, I'm going to go into amygdala hijack, we're going to go into prefrontal cortex lockdown, and I'm not going to be able to do anything. So it's important for the pilot to understand what it feels like and how it feels in themselves. And as we've spoken about before, we've got to be able to control the fear, control the sympathetic nervous system response, and the negative cognitive behaviors. What we're doing here is we're training resilience. We're really not training a what to do, we're training a how to control myself to get out of it, and give them the knowledge and the tools and the techniques to know that they can do it, that they can get out of these situations. So FST versus on aircraft. So Peter's alluded to a little bit. The thing is, important to understand there are limits on both tools. What we do in our extra has limits on it. What happens in a simulator does have limits on it. If we really wanted to go all out, we'd all be doing on-aircraft training on extras, then we'd be going on into simulators and be going and doing, you know, on-aircraft stall recoveries, and it's just not feasible. But understanding the limits on the tools and trying to fit square peg into round hole is not going to work. You cannot take a one glove fits all approach through the training. Threat. The threat is real in an aircraft. The threat and simitis basically go together. When you're putting someone into a simulator, they know they're in a simulator, they know that something's going to happen, but they also know that no matter how bad it goes, they can walk out of it in 15 minutes' time and have a cup of coffee. The element of threat is not there. Understanding that on-aircraft training does bring in that element of threat, that if it does go wrong in an aircraft, as Peter said, it will go wrong, and it can go wrong in the most well, we really don't want to go there, do we? Aircraft specific responses. So again, understanding the way in which your aircraft handles versus what you may be flying. So again, if you're flying something, an on-aircraft type, you know, your PITs or your extra, understanding that the response of that aircraft is going to be slightly different perhaps to the way in which the aircraft that they will be flying handles. So again, what we do is we limit roll rates, we limit G loading. We understand that what they're flying, their Barons or their Chieftains, is not going to respond like an extra. But what you're teaching again is the response and getting them to think clearly about what that response needs to be. So really an appropriate blend of training optimally when we're looking at constructing and putting some of this into the Part 61 MOS and the 121 MOS, taking it out of the AC, is about really making sure there's an optimum blend through a pilot's potential career where they're exposed to all parts. So what can go wrong? Well, a lot can go wrong by teaching this incorrectly. So the pilot can come out with negative learning experiences. Okay, we've got to ensure that what we train and the way in which we train doesn't worsen their already heightened level of anxiety and fear around what we're going to be doing to them. Okay. An incorrectly taught technique will instill a false sense of security. So teaching something wrong is potentially worse than not teaching them anything at all. So it's very important that what we're teaching them is correct. Incorrect techniques. Well, if we're teaching incorrect techniques, again, false sense of security. But in an on-aircraft scenario, an incorrect technique could end up in an actual loss of control in flight, spin, accident. Lack of standardization or non-standardization. I think I invented that word. Pretty self-explanatory. Okay, we can't have blogs teaching this, Shane teaching this, Jeremy teaching this. It's got to be standardized. The message has to be standardized. Inappropriate timing or overload of the trainee, again, recognizing where they are. So making sure that then they're in the optimal level of stress in order to promote that learning experience, not tipping them over the edge. Tip them over the edge, you won't get them back. So ensuring that the way in which the course is constructed, the delivery is constructed and actually provided, we've got to make sure that the timing and the construct is appropriate and it's a building block approach. And again, doing it wrong, scaring the trainee, putting them into a really fearful situation, okay, increases trauma, increases anxiety, you're not going to get them back. So again, it's a very brief overview, but in the conclusion of this, okay, you've got to, the instructor selection, the people you select to do the training has got to be appropriate. The actual instructor training itself has got to be appropriate. The syllabus has got to be appropriate for what you're trying to deliver and what you're trying to get out of it. So there's no point trying to force swept wing, MAC-tuck techniques onto an RAOS pilot and vice versa. An appropriate blend of tools, classroom, device, simulator, aircraft, and being aware of your trainee limits. Most important thing, especially for on-aircraft training, is it's got to be underpinned by a robust safety management system. Okay, so understanding what the flight limits are, what your tolerances are, all that sort of stuff. It's got to be in black and white and never show you cross that line. So once again, really what we are training here is resilience in the pilot, training the pilot to understand they are going to have a negative cognitive response, and that's okay, but they can do something about it afterwards, and no matter what happens, giving them the knowledge and the skills to believe that they can do it. So that's it. So thanks very much. Yep, any questions? Excellent.
Just rearrange things a tiny bit. Paul is next. We might then move Wayne to straight after lunch, if that's okay. So, Paul, we'll try and keep that to within that time bracket if possible. We'll have some time later to catch up on some of the action recommendations. So if we can do that, then we can break for lunch and get ourselves back on track, I think.
I've got a lot of slides and I've practiced it at home, so I'll try and keep it as quick as I can. My talk is to try and help you people in the room give you better new pilots, so you don't have to spend time fixing a few things. So UPRT in general and recreational aviation, a little bit about me. I'm a lamey, 16 years in the RAF, Middle East, Canada, PNG, and I started up a company, Flight Safety Solutions, where I've created a fully compliant electronic aircraft record system that's CASA 43 ready, if anybody's interested. Uses a certificate of release to service instead of a maintenance release. Flight experience, grade 1 flight instructor, RAOS instructor, previously a CFI. My wife is now the CFI of our RAOS training. We do 141 and RAOS training. So my wife looks after that. So we have some really interesting conversations around the Netflix table. Used to fly gliders, and I also do banner towing. So I'd like to take you on a bit of a journey, if anybody recognises the photo. Once upon a time, we all had the passion. The question is, how many people still have it? Let's have a reflection. Did you have to work hard to afford and achieve your flight training? Where did you get your reference material from? Was your flight instructor simply outbuilding? What do you remember from your basic flight training? What was the performance and technology state of your aeroplane? And what part of your journey did you feel, I think I'm getting a handle on this flying caper? The only constant is change, and we have a changing world. And we need to change the way that we teach people, and we've been talking about that already. Maslow's come up this morning. He's got his pyramid there. We have a new addition to Maslow. It's Wi-Fi and battery. All right, we don't have that. We're not feeling secure and safe. So let's have a look at that. Did you have to work hard to afford and achieve your flight training? I know I did. Paid for everything out of my own pocket. Couldn't get into the Air Force as a pilot. But now we can do vet fee. Yeehaw. Where did we get our reference material from back in the old days? This is where we got our reference material from in the old days. And now we got a whole other bunch of sources. Was your flight instructor simply hour building? Well, back in the day, mine wasn't. I don't know about all of you guys, but now it's a perceived pathway to fly that A380. Interestingly, I draw a circle on the board. Everybody wants to be a Qantas pilot when they walk into school. What do you want to do when you I want to fly A380s? I draw a circle with a red line. So that's a pie graph of all the people who want to fly A380s. And the red line is the people who do, and it's probably 10 times as big as it needs to be. So it's a hard challenge. Don't bullshit them on the way up. What do you remember from your basic flight training? It's like drinking from a fire hose. So Shane talked about it. There's no point in taking an RPL student and trying to throw him into UPRT straight away, because he just does not, he or she does not understand the concept of aviation for a number of reasons we're going to talk about. What was the performance and technology state of your aeroplane? Let's talk about this. I learnt to fly power. I started in gliding, learnt to fly power on AUF aeroplanes. Now, the RAOS fleet is the biggest growing thing, and a lot of people will come from that through to GA into your hands. And we use it as a tool. Whoop. We lost the presentation. Oh, there it is. We use it as a tool to help people save money. We do the same flight training syllabus. We use a TechNam and some other aeroplanes. They're really good. Adverse yaw, you have to use your feet. They'll bite you if you're not careful. And then we get them into the Cessna, and it's a doddle comparatively. But I'll take you on a quick journey here. Started off like this in the 70s, and everything was really cool. And CASA said, hey guys, just keep that in your own yard. Don't fly above 300 feet. Don't cross a road. She'll be good. But then people started to die. So the first transition of AUF was two-seat aeroplanes to do flight training. And the Drifter on the left, excellent flight training aeroplane. A whole lot of fun, and really you have to fly it. And then we got really smart. We got enclosed aeroplanes. That's really was the pinnacle then. And then we met another hurdle for recreational aviation. RAOS was born because of the introduction of light sport aircraft. All metal aircraft, two-place, side by side, 120 knots cruise at 18 litres an hour. Then we got this bad boy here. It's TechNam Aurora. Costs as much as a brand new Cessna. Okay, $300,000. You can fly that away in any color scheme you like, so long as it's black. Right. And then, who doesn't want that sitting in their hangar? Okay? That is a piece of work, this thing. Have a look at the specs on that. 151 knots, 4.5 hours duration, stall speed of 35 at 18 litres an hour of MOGAS. Carbon fibre, glass cockpit, excellent. So that's what we're dealing with. We're dealing with people who work at Bunnings on weekdays and they go off and they start playing with stuff like this. So what part of the journey did you feel I'm getting a handle on the flying caper? I didn't feel like in reflection, I don't feel like I knew how to fly an airplane until I became an instructor and started teaching aerobatics. So probably some 1,500 hours, and I don't want to count how much money. So change is with us. It's a dynamic situation. We have to look through it and with a bit of clarity. We can take a chance and keep doing the things the way we're doing, or we can change one little thing and we can make a big change. Loss of control is why we're here. I break it up into three things: training standards, culture, and misinformation. This is what our challenges are today, what I see challenges are. Training standards. The syllabus hasn't changed since 1918. I've got a whole slideshow on that thing. The guys that were at the UPRT conference in August would know that. And we're not keeping up with the changing world. In 1943, the US Navy put out a video about stall and spins, and not one word in there was about angle of attack. Now we know about angle of attack, but we don't teach it because everybody thinks it's about speed. The structure. RAOs, varied and delivered syllabus. Same syllabus, different opinions, different way of teaching it, not the same. We've got out of industry instructors. So we've got people who work other jobs and they come and play flight instructor on the weekend. Not that there's anything wrong with that. It's just that they're not involved in the culture of aviation as much as they should be as an instructor. Instructor development. I know a number of RAOS instructors who are just got their approval, and apart from their 2-year flight review, they don't have any mentoring, and they haven't got anybody helping them with their own personal development as an instructor. So it's a bit of a problem. In the professional world, we got the same thing: varied delivery of the syllabus. Vet fee, trained to a price tag, not to a standard. Might get shot for that one, but that's the truth. Borrow some more to become an instructor to teach the next vet fee intake. Backing up what Shane said, I didn't get taught stalls properly, but I'll go and spend another $30,000, get my instructor rating for a pathway to become an airline pilot. Now I've got to go teach stalls, and I don't want to teach it because I don't understand it and I don't like it. So the next student, and so it goes. Standards. What is competent? That's the big question. We've got ACs on it, and we've got guidance material on it, but we've got instructors and examiners with differing opinions and students with individual expectations. I've had a number of students, why don't you let me go solo? I think I'm ready. That's nice, mate, but it's up to me when you go solo, not when you think you're ready to go solo. So we'll have a look at something here. This is a training record. Young fella came to us from another school. It's all de-identified to protect the guilty or the innocent. And he told us, I'm solo from another school and I'm flown in that aeroplane. I want to go for a fly. Okay, show us your membership and everything's all good. Jump in the plane, let's go for a fly. But we're going to have to start from square one. Get your records up. Let's have a look at these records. Lesson number 1. Trial instructional flight, takeoff, climb, descend, turns, glide, stall, circuits to the flare. 0.8. This is Bob Hoover reincarnated. Flight 2, circuits. RAOS uses a little different competency standard. It's a 5-point competency standard. 3 years competent to solo standard. So after 1.6 hours, this instructor has deemed that this guy's doing circuits to a solo standard. First solo, 5.7 hours. So we started him back at effects of controls. No underpinning knowledge, nothing. So these are some of the challenges. Some of the other challenges we face. Do a lot of flight reviews. And one of the things I like to do is stalls. See if they understand, ask them questions about angle of attack, go out there. This is from the MOS, A5. Stall under straight and level flight. That's the only one that people remember. They don't remember stalls in a turn. They don't remember stalls in a landing configuration. They don't remember any other stalls. As a matter of fact, when they go out and do a stall, we're going from a wings level idle, straight ahead stall recovery, stall and stall recovery from here to there with power applied there. Taking over, let's go and have a chat. That's what we're seeing. These commercial pilots from other places as well. People come and do tail wheel endorsements or want to do aerobatics. Let's go do a stall. No, let's go back to the classroom. Advanced maneuvers, reduce angle of attack. A very poor understanding of angle of attack, a very poor understanding of where relative airflow comes from. A couple of commercial pilot almost ready for the commercial flight test. I put my decathlon model pointing straight up. Where's the relative airflow from? Oh, here. Okay, well, let's have a bit of a talk about some things. Misinformation, social media. Maintenance is a whole different thing, but social media is the go-to place if you want to know something. Go onto a chat group and ask somebody, how do I find the right nut and bolt for this? And how do I find the recurrency requirements for this? Content, anything is fair game. Source data, whatever people want to put up there. Validation, there is no authentication of validation of data. Credibility, the more the followers, the more credible you are. Okay, go out there and do cool shit and people are just going to follow you and try to do what you're doing. Loss of control, speed. Shane talked about it. We all know. That's not the reason why aeroplanes stalled. Misinformation we're talking about here, and I'm not having a dig at anybody. This is just what's out there. ATSB, managing partial power loss, avoidable accidents. Great reading, excellent stuff. But we have to be careful what we write in here. This is how to maintain glide speed. What is the most important is the primary focus to be maintaining airspeed to prevent stalling. Sorry, CASA, shoot me now. Leave the license at the door. Turns in slow flight in the traffic pattern. It's easy to be distracted and allow the airspeed to drop. Climbing turns in a departure configuration. Reaction and turns may distract from speed control. Speed control is a function of attitude control. Attitude and power and flap setting. So I come up with this little bad boy and I've got a whole slideshow on it. Happy to share it with anybody. Stall triangle. Speed, load, angle of attack. Both speed and load are tied to angle of attack. Culture. I don't want to spend too much money. Training, what's the minimum I have to do to become a pilot? I get people come in my flight school and they ask me that. I want to do any idea where I can get some cheap flight training? I say, yep, you go out the door, you turn left and you go and talk to that school up there because you're not flying here. System knowledge, what do I need to know that? It's not part of flying. I just want to go out and move the stick around. Emergency procedures, won't happen to me. Maintenance, I changed my oil, isn't that enough? Is the aircraft owners, the whole regime of another culture. That's a whole nother lesson. Recency and currency. I don't have time anymore. I've got my 3 and 90, so I'm good to go. RAOS has got a really good currency barometer. It's awesome. Where do you fit on this scale, mate? Oh, looks like you're due for a flight check. Let's go. Expectation. Where's the glass cockpit? What, no autopilot? Our RAL's aeroplanes are day VFR light sport aircraft. They don't even have a horizontal artificial horizon. And after a few lessons, they don't have an airspeed indicator after a while. But there's an expectation. What, no TV screen? Perception. There's a pilot shortage, so I'll get my commercial pilot license. I'll get a job right away, right? So if anybody's got any jobs going, I've got some people who want a job. Desire. Hunting for a job. We've been doing banner towing for, since 2012. And Southeast Queensland would have to be the biggest region for the vet schools. In the whole time Since 2012, we've had 3 people walk in the door asking for a job. So all you guys and girls in here, you all went and hunt for a job. 3 people in the Southeast Queensland region. Top Gun effect. The young fella with the training record, he's just like, yeah, mate, I went solo in 5.7. Well, he's got a bit of a reality check. GAN, RA, UPRT providers. It's derived from a FAR 25 document. We've done that to death. Thanks, Peter, Jane. It's for airlines. It's not. There's no standardization and no guidance, and that's why I put together the UPRT conference in August, which was really well received, and I really appreciated everybody coming, including some of the CASA people here. So what's the answer? We did this to get everybody in the room, and it was really good. We had a whole bunch of UPRT providers in the room, and we all were on the same page because I did exactly what everybody else did. Sat down with Doc 111 and picked the bones out of it and said, what's applicable to GA and RA? And then I'm a human. I went, am I teaching the right thing? And then I had some people come who had done UPRT from other providers, not you guys, right? And I said, well, you've done UPRT. Let's go and show me your stuff. Hey, my controls, what the hell? And that was the catalyst for me to try and get everybody in the room to try and get our thought process together. So where is UPRT currently taught? This is what we talked about at the UPRT conference. We got our 0 hours guy. He's ready to rock and roll. We got our RPL, CPL, PPL pilot. He's just passed his flight test. He's all over it. We got our 100-hour pilot. He doesn't need any training. He's good. Got our commercial pilots, graduated from our vet fee schools. We got a guy out on his first job. And then we got the airline pilots. Awesome. And at the UPRT conference, we identified the following. No. Yes. Mandated. But we don't do anything here. And where is the law of primacy? And why aren't we teaching people the right way? Well, I'll put my hand up and I'll say that we are guilty of misinformation. Because we asked at what part of the pilot training are we providing the law of primacy? It's a very, very good question. So just went into the MOS and I had a really good look at the MOS after being spurred on by a colleague. And it turns out that, yep, you guys have got it. These guys have got it. And these guys have got it. It's in the Part 61 MOS, right there. Aeroplane advanced maneuvers, manage abnormal situations. This slide here, straight and level, climbing, descending, what? It's there. Nobody remembers it. They can't do it. Get a flight review. I had a 1,000-hour pilot, been flying for 25 years, did not know that the horizontal stabilizer created a downforce. He looked at me in the face after we did a whole talk about stuff and he goes, you got no idea how many questions that answers. 1,000 hours. Reduce angle of attack. The other side of the critical angle, nobody's got a clue. They don't even know what's going on. These are commercial pilots and people who've been flying for a long time. Part 61 MOS says, recognize wing drop at the stall, avoid the spin, perform the recovery. Here's the range of variables in accordance with published procedures and maneuvers performed within operating limits of the aeroplane. Don't use an aeroplane that's not approved for intentional spinning. The DA-40 accident. Why was he doing it? Underpinning knowledge. We're still on A5. Aerodynamic, aeroplane operational considerations. I had a commercial pilot doing a flight instructor rating come down for a spin endorsement. Never side-slipped an aeroplane. Never. Relationship between angle of attack and stall. Doesn't exist. Dangers of unbalanced flight. Keep it in the cage. My wife come up with that one. Keep the ball in the cage. balance, balance, balance. Principle of stick and control at the point of stall. That's stall stick position. Yeah. Would the outcome be different if the pilot knew about stall stick position? I don't know. But it's a good example. Priority given to reducing angle of attack during the stall, higher stall speeds when the aeroplane's turning. Commercial pilots who don't know what a VG diagram is. It's a great tool to understand. Doesn't take long. Contents of the flight manual. But a recent UPRT student come from another provider who did it 2 weeks ago, not you guys. Could not explain to me the difference between a slip and a skid. Could not explain to me the correct answer for what's more dangerous, a slip or a skid. He got a 50-50 chance and he blew it. And here's another one. Stall recovery. Nose pitch straight down, full power, my controls. Show me a spin. Into the spin, punch the stick right forward, tucked under, wanted to pull through. My controls, push, roll, recover. This guy had just finished 5 hours of UPRT and 3 hours of aerobatics. Signed off in the logbook, not the UPRT, but the aerobatics. So, A6, manage abnormal situations, skills and knowledge, control the aeroplane, recover from unusual, nose high, nose low, wings level, apply corrective action. I'm whizzing through this because we've got to go to lunch. And underpinning knowledge, prioritize activities in emergencies, normal situations. Startle effect, right? Contents of the flight manual. Our little friend who did the UPRT did it on a Robin aircraft. Couldn't explain to me the pair method. He flies Cessna and Cherokee aircraft normally. What did he learn from that? How to kill himself, probably. We already know the results of using the incorrect spin recovery. They're the 3 places that all of those competencies are there. A5 and A6, 3 times. And we're producing people who can't fly the aeroplane. So if we looked at the low-level flight activity endorsement and add in there about managing kinetic and potential energy and understanding and managing the aircraft energy state, we might be onto something. We'll talk about that in a sec. Paddy Wagstaff at the NTSB Pilot Training and Education 2018. Anybody sit through the 6 hours of that at all? Anybody know of it? Yeah? She said, technology is not a substitute for basic flying skills. And she said that when a couple of really smart guys from Embry-Riddle started working on a device on the aeroplane to project in your glasses your angle of attack information. So while you're in the circuit scanning, you could see what your angle of attack is. And what Paddy responded to that was, technology is great, but why don't we just teach people to fly the aeroplanes properly? So what if, and we'll leave you this with lunch, what if we just taught the content better? All these resources that we got that you guys are dealing with, that we have been using in the lower end, we're trying to make something for us. We've already talked, because what Peter said about the differences between FAR 25, FAR 23, it's for airline stuff. It doesn't apply to us. The principles apply, but it's not for us. So this is, everybody that was at the UPRT conference, we all spent copious amount of hours of our life trying to build something from something that's not written for us. So we need to work smarter, not harder. We don't have to reinvent the wheel. What if we had a guidance development working group, CASA, to make a new MOS unit, A6.7, because it stops at A6.6, UPRT. But we've already heard, and I agree, UPRT is perceived as an air transport category activity. Yes, it is. UPRT is confused with aerobatics. I was talking to the CFI of a well-renowned tailwheel flight training school in Camden who do aerobatics. And I said, I didn't invite you to the UPRT conference because I didn't see UPRT on your website. Did you know about it? He said, no, I didn't. And I said, well, we're trying to do this and do that. He goes, well, we teach aerobatics and it's all unusual attitudes. So I suppose in a way we are teaching UPRT. That's where I lost interest. He doesn't understand the concept, but there's a perception. So he might get on the bandwagon, take Doc 111 and make it something and then sell it. But it's not going to be the outcome that we need, right? UPRT procedure is scary. UPRT is optional. Lock-I term is more readily accepted within GARA because people like Neil, who's going to talk this afternoon, done a lot of work and people talk more freely. Would you agree? They say loss of control. Oh yeah, we got to do something about loss of control. You say UPRT, they go, oh yeah, I don't know. Loss of control awareness has already been addressed. Prevention training would be a more digestible term. So what if we had a new MOS unit A6.7 UPRT, but it was called loss of control in flight prevention training? Just shooting the idea. So it would contain embrace parts of A5, A6 elements, the low level handling, talking about energy states of the aeroplane, include startle distraction management. And then possibly for the commercial guys and girls, doing the EASA FCL 745, if that's the way that we're going. But the most important thing is we have to develop flight instructor competencies, exactly what Shane was talking about, for the delivery, the appropriate and effective delivery of these MOS elements, which could be 6.7. It would be a train the trainer in addition to maybe an addition or an option. So you can have your normal flight instructor. So a normal flight instructor doesn't teach design features unless he gets a design feature training approval. So he can't teach MOS 6.7, which doesn't exist yet, if he doesn't go and do a UPRT delivery. I don't know. I'm just throwing things around. That's why we're here, right? So draft an appropriate, accurate, and achievable guidance material for industry because, John, you mentioned before, send it out to industry, let them embrace it, let them deliver it. So we're not talking about doing anything new. When we were together in August, we were going like, oh, we'll have to do this and we'll have to do that. We don't have to do anything new. It's already there. We just have to do a standardized loss of control in-flight prevention training syllabus, publish the accurate guidance, adequately train the flight instructors, and ultimately give effective training so that we can address the issue. Question?
Thank you, Paul, and everyone who's facilitated this morning. Peter, on the agenda, Peter gave his presentation earlier, so that this afternoon we've got Sanju Advani, his name wrong, coming in straight after lunch at about 1:15. Okay, so we're going to break for lunch right now. Lunch is outside. Please help yourselves, enjoy, and we'll see you back here very soon. Thank you. Everyone online, should I take a break? I'll put it in the chat what time we're coming back. And Sanju, we've just spoken, John and I, and we'll talk to you about your presentation online, I guess, but I'll have it ready. Any questions from online? No. All right, thanks, team. Apologise about the sharing issue before.